What's happening, everybody? How are you? Hope you're all well. Just wanted to go over a couple of things related to circles. We're going to start up top here, some properties. So here you have this auxiliary line R and R, the radius of the circle, and then you got this purple line R right here. That's the radius too. That is perpendicular to the chord that it goes through. When you have a radius perpendicular to a chord, it cuts the chord into two equal parts. So you've got these right triangles here. You can use a squared plus b squared equals r squared or c squared. So often you'll be asked to find one of these lengths. The property of these, the perpendicular bisector of the chord combined with Pythagorean theorem is key to understand. Okay, this next one, you got this circle, you got these two chords going through the circle that are the same distance away from the center of the circle. So that line segment and that line segment are the same. When that happens, the chords are the same length. And the measure of the intercepted arcs on the outside are congruent as well. Third situation, pretty straightforward. You have this tangent line. Tangent line is 90 degrees to the center of the circle and only touches the circle in one point, called the point of tangency. You can look at it this way. If I extend this radius to create an angle that exits the other side of this circle, it includes half the circle, 180 degrees. Since this is an inscribed angle, it's half the measure of the intercepted arc. So 180 degrees here, 90 degrees there. In this situation, you have a secant A, a secant C. You have an interior portion of a secant. It's a chord there and a chord there. Then you have these two exterior portions that terminate at the same point, creating this angle outside. So secant-secant relationship, these parts are congruent. When you multiply the secant times the exterior part of the secant, it's congruent to the other secant times that respective exterior part. So A times B is congruent to C times D. That intersection happens on the inside. A times B, this times this, is congruent to this segment, C times D. And then probably the most challenging part to understand here on this one, it's confusing just because it's a little different. You have secant B, tangent A. So same idea down here. The secant times the exterior part, B times C, is congruent to A times A, or A squared. When it comes to angle measure, and those have all to do with lengths. When it comes to angle measure, think of it this way. 360 degrees in a circle, right? Doesn't matter how big the circle is. I'm not considering the length of any part here. It's all about looking at degrees. When you have a chord-chord relationship, the vertex of the angle is on the inside of the circle. All of these other situations, the vertex of the angle is on the outside of the circle. Okay, with the exclusion of the one we just went over, the tangent line. Okay, so when you're trying to find the measure of the angle, and the angle is on the inside of the circle, you average the intercepted arcs. So in other words, x plus y divided by 2 is equal to z, and that z is equal to that z because vertical angles. So x plus y over 2 equals z. That's for chord-chord. For any of these situations where the angle is outside of the circle, you subtract the arcs and divide by 2. So it's the average of the difference. So x minus y divided by 2 is z. X minus y divided by 2 is z. X minus y divided by 2 is z. So there's the formula for angles that occur outside of the circle. Secant relationship, secant tangent relationship, and the ice cream cone, tangent. Something to note about the tangent relationship, x and y added together, since they only have a point of tangency, right? And they both terminate or land on the circle in one point. X plus Y would be the full circle, so 360 degrees. All right, have a great day today.